We're going to find out the arc length S of the cardioid with the polar equation R equals to 1 plus cos theta. And this is how the cardioid looks like from 0 to 2 pi. Okay. Then also we are interested in the surface area as generated by revolving the cardioid around the x-axis. So we have x equals to 1 r cos theta, y equals to r sine theta in polar coordinates. But r is given as 1 plus cos theta. So when we put that, we get 1 plus cos theta times cos theta, 1 plus cos theta sine theta. So now, what is the formula for the length of arc? Our length of arc is given by 0 to 2 pi, because that's what your limit on theta is. Instead of t, you have theta, square root of dx by d theta, the whole square, plus dy by d theta, the whole square, d theta. So instead of t, we have theta here. So let me write down, what do we get? We get dx by d theta is, so you can write this as cos theta plus cos square theta, and you can write this as sine theta plus cos theta sine theta. So dx by d theta is going to be minus sine theta. So let's write it down directly in the equation. So we have 0 to 2 pi dx by d theta is going to be, derivative of cos theta is minus sine theta minus 2 cos theta sine theta, the whole square. This is our dx by d theta. Similarly, dy by d theta is going to be cos theta. Now, instead of doing it, instead of basically applying the product rule, I can see this as sine theta plus cos sine 2 theta divided by 2. Helps me to not use the product rule. So derivative of sine 2 theta by 2 is cos 2 theta, the whole square d theta. In fact, this can be rearranged. We have 0 to 2 pi square root of sine theta plus, now 2 sine theta cos theta can be written as sine 2 theta, the whole square, plus cos theta plus cos 2 theta, the whole square, d theta. So now we want to be able to evaluate this integral. One way is to expand this out now. So we get 0 to 2 pi. This will become sine square theta plus sine square 2 theta plus 2 sine theta sine 2 theta. So that is just the first part. So the second part, we have cos square theta plus cos square 2 theta plus 2 cos theta cos 2 theta d theta. Now we have again 0 to 2 pi sine square theta plus cos square theta gives us 1. So this guy plus this guy will give me 1. Similarly, sine square 2 theta plus cos square 2 theta will give me 1. So we are left with 2 plus, now from these two guys I can take 2 common. I'm left with sine theta cos sine 2 theta plus cos theta cos 2 theta d theta. Now the formula for, so hold on a second. So we get the following. So this simplifies to, we get 0 to 2 pi. If you simplify this, this is going to be, you can take 2 out. 2 will come out as square root. We get 1 plus. And now this can be combined into cos of 2 theta minus theta, which is cos theta. Now this can be written as root 2. Now apply the double angle formula. 1 plus cos theta is cos square theta by 2 square root 0 to 2 pi d theta. So this is going to be, so instead of evaluating it from here to here, we should evaluate it from 0 to pi. Yeah, because here the angle is 0, and when it comes back here the angle is pi. So let's evaluate it from 0 to pi. Zero to pi. So this is going to be root 2 cos square theta by 2 becomes integral of, so cos square theta will become cos theta by 2, and integral of that is sine theta by 2 divided by theta by 2. Sorry, divided by 1 over 2. 0 to pi. So this will become root 2 times sine of pi by 2. So this will multiply up to become 2 minus sine of 0. So we get 2 root 2. This is your length of this part of the arc. So total length is going to be, so therefore total length is going to be 2 times L, which is 4 root 2. All right. So similarly, let's write down the expression for the surface area. Again, if you want to rotate this around, we don't want to rotate the whole thing. We can just rotate from 0 to 2 pi. So the area would be, surface area is given by 0 to pi, 2 pi. So we are looking for surface area generated, right? So it's going to be 2 pi f of x. F of x is same as y. So y is r sine theta, which is going to be 1 plus cos theta times cos theta times dx by d theta square plus dy by d theta square. So times, if you simplify, it will be times root 2 times square root of 1 plus cos theta d theta. And this can be dealt in the similar manner. Okay. All right, so recall, if you have a circle, so if you have a circle of radius r, and if you look at this sector, if this angle is theta, then the area of this sector is given by area of this sector, area of sector is given by half r square theta. Yeah. So the idea is, well, it's clear. Why is that the case? The total area, a circle area is what? Area of circle. Circle area is pi r square. So the total is 2 pi. If you're just wanting the one with the theta, you're taking at what? You're taking theta upon 2 pi slice of the whole area, which is pi r square. Yeah, it's going to be area of the sector. Yeah, it's basically theta by pi by 2 ratio of pi r square, which will give you that it is half pi and pi will cancel, r square theta. So this is the area of the sector. Now we want to basically study the case. So we want to study the case when we have, what if the area is not a circle? So what if f of r theta is not a circle? So here you have this curve is a circle, right? So if I copy this here, say, if I copy this here, if this angle is theta and this length is r and this length is also r, so it will look like a circle for us, right? And in that case, area of this shaded region is going to be, if this angle is theta, then we have area of circle is going to, area of this sector is going to be, following the same logic, is going to be half r square theta. Now we want to mimic the same thing. So we want to do things in polar coordinates, but what if we do not have a circle? So let's look at the following. So you want to find out area of the following object. So, and this object is not like a circle, so it's wavy like this. Okay. So let's just draw it slightly below. So this object is wavy like that. So we still want to find out area of this shaded region. So let this angle be A. This total angle be B. So this is theta equals to B. And we want to find out what is this region. Okay, so we want to find out what is this region here. Okay, so how do we go about it? We want to find out area of this region. So like in Riemann sum, what we did was, even though we did not have rectangles, we approximated areas by rectangles. So we'll follow the same trick here. We'll approximate areas by sectors of this form. Okay. So what we'll do is the following. We will take a small, so we have, again, we have R. So what is the scenario? The scenario is R equals to f of theta. And you want to find out what is this area enclosed. So in this case, we'll make circular segments. So let's make a small slice here. So let's make a small slice, small slice. Okay. Now this angle here be delta of theta I. Let this be Ri. And if you really take small, then this will also be Ri. Okay. And then what we're doing, we are trying to find out area of this slice now. So what is area of this? This slice. Okay, so let's find out area of this slice now. All right. So what is the area of this segment? Again, if we approximate it small enough, this is going to be, both of them can be roughly thought of as an Ri of same. So we can think about this as a small sector. So delta area of delta AI is going to be, so let's call this area as delta AI, is going to be half Ri square theta delta theta I. Yeah. And then your actual area is adding all these areas up. So actual area is limit as, so first of all, you add all these areas. So half Ri square delta theta I. Then you're adding all of them up. And then you're taking limit to make it the approximation better. So if you recall, if you make connection with Riemann sum, this is going to be, let's rewrite it, limit as n goes to infinity, summation I going from 1 to n, half. Now Ri is basically, you have R equals to f of theta. This is how your function, your curve is given by, right? In curve, like how you wrote y equals to f of x, you have to give connection between the variables. So in polar coordinates, generally we write R equals to f of theta. So Ri will be replaced by what? F of theta I square delta theta I. And then you take this limit. This is nothing but integral f of theta I. So f of theta square now divided by 2 d theta, and the limits of integration are a to b. So the formula for area is a equals to a to b half r square theta or f theta square d theta. So this formula gives us the area. So let's reiterate. This is how the formula for the area of a polar region is given by. And oftentimes it's written as half r square theta d theta, r square d theta, because it's easy to remember, right? It connects very easily to the area of the sector. So let's work on a problem. So first, sketch a cardioid 1 plus cos theta and find the area it encloses. So we want to sketch a cardioid. So let's sketch a cardioid now. So r is a distance from the origin, right? So now let's see how does cos theta looks like. So cos theta is, so since we want to go from 0 to 2 pi, at least we are hoping that will make the whole thing. So let's draw that. So when you want to draw cos theta, cos of 0 is 1, then cos of pi is 0, pi by 2 is 0, then it goes negative, becomes minus 1 at pi, then comes back to become 0 at 3 pi by 2, and then goes back up to become 1 at pi, 2 pi. So this is how cos graph looks like. So now this will help us to draw the whole thing. So let's see, when theta is 0, what is r? R is distance from origin is going to be 1 plus 1. So we'll be 1, 1. So we'll be here. So we have 1, 2. So at 2, when theta is 0, you get 2. But as you keep going further, the r values goes further and further, becomes 0 at pi by 2. So when the angle is pi by 2, it goes and becomes what? 0. So from here, it starts decreasing now and becomes 1. So it is 2 here, 1 is here. So it will basically start decreasing. 1, 2, start decreasing to become 1. After that, it basically goes negative, right? So at pi, it becomes minus 1. So you have 1 plus, so 1 plus minus 1 will become 0. So at pi, it goes down further and becomes minus 1. Now after that, it's really symmetric, right? This is, so you will see that the same thing will follow. So this is your equation of the cardioid. Sorry, this is the graph of your cardioid in the polar coordinates. Now, what is the problem asking us? Find the area it encloses. So what we'll do is the following. We will find the area above and double that area. Okay, so we'll find this area because then the limits of integration are easier to work with. So we'll find this area and double this area. So now what is the angle here? So this angle is 0, and here we have pi. So this total angle is pi. So what is the area of the the cardioid? Is going to be f of theta whole square divided by 2 d theta, integral from where to where? From 0 to pi, and then we double it to get the whole area. So this is the total area of cardioid. It's called cardioid because it looks like a shape of the heart, right? So now r is f of theta. So we can now proceed on finding this limit. So we have 2. This 2 will come out. We'll cancel it. So 0 to pi, 1 plus cos theta, because that's what the formula for f is, 1 plus cos theta d theta square d theta. So now we need to integrate this. So we have 1 plus cos square theta plus 2 cos theta integral 0 to pi d theta. Now this can be integrated, but we need to have double angle formula so that we can integrate that. It's going to be 0 to pi 1 plus. Now cos square theta can be written as cos 2 theta plus 1 divided by 2 plus 2 cos theta d theta. Now we can integrate. We don't need to simplify further. So this is going to be theta. Integration of cos 2 theta is going to be sine 2 theta divided by 2. Integration of 1 is going to be theta, the whole divided by 2 plus 2 sine theta. Limits are from 0 to pi. Now note that none of them will survive. This will not survive because cos sine 0 is 0 and sine pi is 0. Similarly, this will also become 0. So what will survive is theta plus theta by 2, which is 3 theta by 2. So 3 pi over 2. So this will be your area. So area is 3 pi over 2. So again, consider the cardioid from the previous example. So we had r equals to 1 plus cos theta. That was a cardioid from previous example. And the circle centered at origin with the area equal to the cardioid. So we don't know what this circle, we do not know what the radius of the circle is, but we know that area of circle is equal to area of cardioid. So this means pi r square equals to area of cardioid was what? 3 pi by 2. So this means r equals to square root of 3 by 2. So r is square root of 3 by 2, the whole square root of 3 by 2. So this is your r. Now find the area inside the cardioid but outside the circle. So what area are we interested in? We are interested in this area here. Yeah, we are interested in this area here. Okay, so let's just shade this area. Yeah, so we are interested in this area. All right. So what we'll do is the following. We'll find out half of this area. Yeah, and then double it. So what we need to do is we need to find the intersection of these two things. So we need to find out these angles, right? And so we'll find out this angle and then double it up. So what is this angle? Okay. So for that, we need to compute the intersection. So the intersection is going to be, so step one, find intersection points. Now to find intersection points, you have to basically equate r equals to root 3 by 2. This is equation of circle. Equation of cardioid is r equals to 1 plus cos theta. When you equate it, you'll get 1 plus cos theta equals to root 3 by 2, or this implies theta cos theta equals to root 3 by 2 minus 1. And then when you take the inverse, it actually get two angles, right? Because cos of minus theta is cos theta, right? So, but we'll only work for, so we have, so this is going to be cos inverse of plus or minus theta equals to cos inverse of plus or minus root 3 by 2 minus 1. So we'll be only interested in the plus 1 because we are only going to exploit the symmetry here. So exploit symmetry. So how are we going to exploit the symmetry? Well, area is twice, 2 times shaded area above x-axis, right? So then we have integral is going to be, so what is the total? So the first outer, so you have to basically do outer curve minus inner curve. So the outer curve is of the cardioid, right? So we have the outer curve is cardioid. So we have, this is going to be 2 times 0 to angle is cos inverse of root 3 by 2. So this whole thing is root 3 by 2. So root 3 by 2 minus 1. Then we have 1 plus cos theta, the whole square. This is your, the outermost curve, right? Half r square by 2. So this by 2 minus the next one, which is r is root 3, the whole divided by 2 square by 2 d theta. So we want to integrate this guy, and the integral of this will give us the answer. So let's embark on this. So let's finish this problem. So we have 2. This is going to be, take the other 2 out as well. 0 to cos inverse of root 3 by 2 minus 1. So cos inverse of root 3 minus 1. So the whole thing, right? Not just root 3, cos inverse of the whole thing. So let me put a bracket at the appropriate place so that it's clear what is. Okay. So, and we are looking at the positive angle here, right? So we have 2 by 2. We have 1 plus cos square theta plus 2 cos theta minus 3 by 2. So this is going to be 1 by 2 minus 1 by 2 actually, because you're subtracting 3 by 2. So we have minus 1 by 2, 0 to cos inverse of root 3 by 2 minus 1 plus cos 2 theta plus 1 divided by 2 plus cos theta d theta. Now we are ready to integrate it. So this is going to be minus half theta plus sine 2 theta by 4 plus, so half and minus half and plus half should have cancelled each other out. So we did not need to write that. So we get then cos theta integral is sine theta. Again, limits are from 0 to cos inverse root 3 by 2 minus 1. Now, when you put 0, of course, you'll get 0. So at the end, we are looking at sine of 2 theta by 4. So 2 of cos inverse of root 3 by 2 minus 1 plus sine of cos inverse of root 3 by 2 minus 1. So if you use your calculator, the answer turns out to be 2.0581, because all you have to do is compute cos inverse. So cos inverse of root 3 by 2, 3 by 2, 3 by 2, 3 by 2. So cos inverse of that is 1.344 radians. So that's one way of dealing with this problem. Another way of dealing with this problem is drawing triangles. So we can draw the triangles. Okay, so let's draw a triangle. So in this case, if this is your theta, cos theta is opposite side, sorry, adjacent side, which is root 3 by 2 minus 1 upon hypotenuse. So you can appropriately calculate what is the value of this guy. So this guy is going to be, using Pythagoras theorem, is going to be 1 minus root 3 by 2 minus 1, the whole square root. So that would become, if you want to simplify this, it will become, this is equal to, so a square minus b square, this is going to be a plus b times a minus b. So a plus b is going to be root 3 by 2 a minus b is going to be 1 minus of minus will make it plus, so plus 2 times root 3 by 2, and then square root of this whole thing. Okay, so you can do it that way, or you can basically use your calculator to finish this problem off.